All right, today what we're going to work on is solving logarithmic equations. You guys are definitely going to want a calculator for this. So a log equation, just got the definition at the top. It's got to be an equation that has one or more logs within the problem. And so for some of these, we're going to be applying properties, but for the first set of equations here, I have just one logarithm in each. So what you want to do to get rid of a logarithm is convert it to an exponential. So that's what we're going to do. And if you do not have a base, like I don't have a base in this first equation here. Okay, remember that's going to be base 10. So just keep that in mind. I like to personally write it in, but that's my thing. So first thing you want to do is isolate the logarithm. So I want to get the log alone on one side, and then I can convert it to an exponential. So the first thing I would actually do here is add this 10. So I have log, and I'm going to just put the base in there, add 10 to negative 8. So we're going to get 2. All right, then get rid of the log by converting this to exponential form. So base of the log is going to push that 2 up in the air. Base of the log becomes base of your exponent, and so there x is just 10 squared, and then I'm actually going to square 10. That'll give me 100, and that's my answer. That's all I got to do. The second question, because I have parentheses, I'm taking this log of x plus 4 all together. I don't want to add anything out of those parentheses or subtract anything out. What you want to do here first is just go ahead and convert this to an exponential to get rid of the log. So base of the log becomes the base of your exponent, so that 2 is going to push that 6 up in the air to being an exponent that gets rid of the logarithm. 2 to the 6th power is 64, and so then all I have to do there to solve that, subtract 4, and so x is going to be 60. Now, we should check, just in case you're not going to see this in any of the problems, but you cannot take the log of a negative number, so you should just do a quick check. Make sure if you plug this back into the original problem that you're not going to have a situation where you take the log of a negative number. Both of these cases we should be okay, so it's not going to be an issue. Okay, couple ways to do this problem here that you've got on the end. I just want to write above here. This actually is an application the power property that we talked about for logarithms. Remember, if you have something out in front here, that's actually an exponent on whatever you're taking the log of, but in this format, it actually makes it a little bit easier for us because you can just go ahead and start this problem out by dividing by 4. Okay, so then I get the log base 8, 7 minus 2x is negative 12 divided by 4 is negative 3. Now, this turns into the problems we were just doing. Get rid of the log by converting this to an exponential. Don't add or subtract anything out of those parentheses. We're taking the log of that whole thing, so I can drop the parentheses after I change this to an exponential, but don't try to get the x in the parentheses alone or anything like that. So this will be 8 to the negative 3. Okay, now you don't have to write this out. 8 to the negative 3 is the same as 1 over 8 cubed. And to be honest with you, it's 1 over 512. I would just do the rest of this problem on my calculator. So the rest of this problem, what you would do next, you would subtract 7, and then you'd have negative 2x is, and we could just do 8 to the negative 3rd minus 7, which I'm just going to do on my calculator here in a second. And then I'm going to divide that whole thing by negative 2. Now, you're going to see in these directions, it'll say round to the nearest thousandth as needed. I didn't need it for the first two problems, but for this one, we will. Okay, so I just grab my calculator. I'm going to type that all right into the calculator, 8 to the negative 3rd. And then we are going to subtract 7. And I'm going to go ahead and hit equals, and then I'm going to divide that by negative 2. So to the nearest thousandth, that's 3 decimal places. So I'm going to have 3.499 as my answer. And if you want to plug it back in to check, I might check it kind of right in here. Plug that in and see if that's the same decimal as 8 to the negative 3rd. We're not going to be able to do log base 8 on the calculator, so that would be where I would check that. For example 2 here, what we're going to do is we're going to actually have some equations that have more than one log in them. So we want to see if we can apply any of our log properties is what you want to do. So for this first one, adding, if you guys remember, turns into multiplication as long as you have the same base. So these are both base 3, so we're good with that. So I'm going to squish this together as a single logarithm, and in doing that, I would have 9 times 5x. Which I can go ahead and multiply, and that's just going to give me 45x. And then from there, once you've got it down to a single log, you can get rid of the log by converting to an exponential, which I'm just going to swing this 3. The base of the log is going to push that 4 up in the air. The 45x is going to stay right where it's at. And when I swing that base over to the other side, creating an exponential, that gets rid of the logarithm. And so 3 to the 4th power is just 81 here. Divide both sides by 45, and I'm just going to grab my calculator here real quick. 81 divided by 45, and I got 1.8. If you want to write that as a fraction, I just did math enter there. That should be 9 over 5. So I'm going to put 1.8, or as a fraction, 9 over 5. Okay, for the next one, if you have a number out in front of a logarithm, that becomes an exponent on whatever follows it. That's your power rule. So I'm just going to write these in real quick. This should be log base 2 of x to the 4th minus log base 2, same basis here. Now this will be 3 squared. If you want to go ahead and skip this step, that would become 3 squared is 9 there. Okay, now further, if you have subtraction, when you squish that back together, that's going to turn into division. So I have the log base 2, whatever comes first, which is the log base 2 of x to the 4th, that's going to go on the top, and the 9 on the bottom. Notice this is just a single log. I don't have a log in the numerator and the denominator both. It's just out in front, single logarithm, one word log written by itself. Now, once I have that, I can get rid of the log by changing this to an exponential. So x to the 4th over 9 is going to stay where it's at. Base of the log is going to become the base of your exponent. So 2 is pushing that 7 up in the air. And 2 to the 7th power, I'm going to do on my calculator real quick, is 128. Okay, and then this is completely up to you however you want to do it. I would just go ahead and take and multiply both sides by 9 there to get that out of the denominator. So then I'm going to have x to the 4th, and then 128 times 9 is going to give you 1,152. Okay, now notice in the directions here, round to the nearest thousandth. Honestly, if it's me, to push less buttons on the calculator, what I would do, I'm going to take both sides here to the 1/4 power. And normally I would tell you the 4th root here, this is the same as the 4th root if I do that bottom out. Normally I should have a plus and minus here, but in this situation, if you look, actually let me pull that back down. If you look back to the original problem, if I plug in a negative number right here, I'd be taking the log of a negative number. If I write the 4 out in front, that wouldn't affect it here because the 4th power would cancel out a negative, but a 4 out in front, written like that with the power rule, if I put in a negative number there, I wouldn't want to take the log of a negative number because that's not defined. So I am not going to put the plus and minus here because a negative would cause me the square root of a negative number. So I'm going to do 1152 to the 1/4 power, or 0.25. And so for this one, x is going to be 5 we're going nearest thousandth, so that's 3 decimal places. So it would be 826 for this one. Okay, and then I have one more. And again, I'm going to squish these together as a single logarithm. Both of them are base 8, so I can apply the properties. So I'm just going to write a log base 8. If subtraction is what you have in the problem, I'm going to do 6 minus 3 over x would turn into division. That's to the -2. Okay, get rid of your log. We're going to swing our base. Base of the log becomes base of the exponent. Gets rid of the log, so that's 8 to the -2 power. different ways to solve this. If it's me, I might remember that 8 to the negative 2 is 1 over 8 squared. And the reason I would use this, I've got my variable in the denominator here. 8 squared is 64. I just made a little proportion there, then I can cross multiply. So cross products have to be equal. 6 times 64 is going to give me 384. Equal 3x times 1 is just 3x. You're going to divide both sides by 3. And my answer there is actually a nice number. It's just going to be 128. Okay, now some of these on the back are a little bit trickier. Some of them not. It just depends on the question. Each one's a little bit different. The first one I have on the back, I just have log base 2 of 8x plus 2, log base 2 of 16x plus 4. Now I'm looking at this and I'm like, sweet, because these are both log base 2. So if they're both log with the same base, log base 2, that forces whatever I'm taking the log of for both, that has to be equal. So I can just get rid of the log there, not even think about it. The equation I need to solve here, the 8x plus 2 has to be equal to 16x plus 4. And however you want to solve it, I'm just going to go 2 steps in one real quick. I like to keep my variable positive if I can. So I would subtract 8x from both sides, and I'm just going to subtract 4 within the same step. This is negative 2, and that's going to be equal to 8x. So x is going to be negative 2/8 or negative 1/4. And then I just want to do a quick spot check here. Make sure you are not taking the log of a negative number. Now, if I plug that back in here, if I do 8 times, that'd be negative 0.25 plus 2. We're okay. We're not taking the log of a negative number. If I do 16 times that negative 1/4 and then plus 4, we're okay. We're not taking the log of a negative number. So we got negative 1/4 there. Okay. Now, these other ones here are going to be a little bit with the properties. So what I have in this example, I have log base 6, x minus 4 equals 2 minus the log base 6 of x plus 4. What I would tell you here is if I've got another number involved, I've got this 2 involved here, what I would actually do, I'm going to add this log base 6 of x plus 4 to the other side, and that way, when I do that, what I can do, I'm just going to use my properties of logarithms to rewrite that as a single log. But I have that 2, so it's not like the last question where I can just set the logs equal to each other. Okay, so what we have here then is going to be a product rule. Adding turns into multiplication, so just put that single log out in front. You're going to do x minus 4 times x plus 4. Now, this is just a little FOIL situation. This is a difference of squares. I'm going to get the log base 6. I've got FOIL or box, whichever you like better. You got x squared plus 4x. Then you'll get a minus 4x and minus 16. So log base 6 of x squared, this is actually a difference of squares here, minus 16 equals 2. Once I'm there, I'm going to get rid of, now this, I mean, you don't need parentheses, but technically I'm taking the log of those two things multiplied together. So don't want to add the 16 to the other side. I should have kept that in parentheses because I'm doing the log of these multiplied together. Here is where you want to get rid of the log by swinging that 6 to the other side, converting this to an exponential. You're going to get x squared minus 16 is 6 squared as an exponential. So we're going to end up with 36. I'm just going to add 16. Sorry, I'm kind of bleeding into the next question here. And that's going to give us 52. And then ultimately, I want to take square root here. And again, I just want to do a little thing. Normally, we take a square root, we got the plus and minus, right? In the original problem, if I have a negative number here, not here, because it'll be not necessarily a bad thing, but here, if I put in a negative number for x, I'd take the log of a negative number, and we can't do that. So I'm not going to put a plus and minus in this problem. It's just going to be a plain square root of 52, which is going to have our x value to the nearest thousandth, being about 7.211 for that question there. For letter F, I just scooched this back up a little bit. I've got 2 logs on the same side, and I've got a third on the other side. There's some different ways to do this, but what I might do, especially since this is just a log of 8, just a number here, let me put together the ones that have the variables on the left side. I'm just going to squish that using my log properties. If I do that, just single log out in front, subtraction turns into division, so we'd have x plus 1 over 2x minus 3, and then that would be equal to the log of 8. Now, log with no base is a common logarithm, so both of those would be log base 10, even though it's not written in there. And so if I have a log of the same base equal to another log of the same base, then whatever I am taking the log of, those have to be equal. So I'm just going to dispose of those logarithms. And I'm going to have x plus 1 over 2x minus 3 has to be equal to 8. If it's me doing this problem because I've got variables in the top and bottom, I'm just going to turn 8 into a fraction by writing it as 8 over 1. And then I would just tell you guys, let's just do a proportion real quick. So we'd have to do, with our cross products, a little distributive property here. And really, I only have to do that with the 8. This would be 16x minus 24. 1 times x plus 1 is just going to be x plus 1. And then up to you, I'm going to do 2 steps in one here, and I like to try to keep my variable positive if I can. So I'm going to subtract x, and actually in the same step, I'm going to add 24 to the other side. So this is going to end up giving me 15x is equal to 25. And we're just going to divide by 15 real quick. And if you want to write that as a decimal or a fraction, it's completely up to you. 25 over 15 is going to give me 1.6 repeating, which is 1 2/3, or if I want to write that as a fraction, this would be 5 over 3 if we reduce that. Okay, and I have one last problem here. I've got 2 logs on the same side, and to get that as a single logarithm, let's just try and put those together with our properties. They're both base 3. Addition is going to squish together as multiplication, so I'm going to do log base 3, and I'd have 3x minus 18. We're going to multiply that by x, and then that's just equal to the 4 on the other side. So I've got log base 3. This would just be a little distributive property here, so we're going to have 3x squared minus 18x, that's going to be equal to 4. And then what I would do there is get rid of the logarithm. Let me scooch this up a little bit, see if I got some more room. Nope, I really don't. We're going to get rid of this log by changing this to an exponential. So 3x squared minus 18x. And then base of the log pushes that up, that 4 up in the air to be in an exponent. So it's going to be 3 to the 4th. So I've got 3x squared minus 18x. This would be 81. And then I'm looking at that going, oh my goodness, we got a quadratic. Now, what I would tell you here, all 3 of these numbers are divisible by 3 as the greatest common factor. So let's just divide everything by 3 real quick. So we're working with some smaller numbers, make it a little easier to do. This would become x squared minus 6x. 81 divided by 3 is 27. Let me just come over here for some more space. Now, this is up to you. You could complete the square, which wouldn't be bad to do here. You could factor. You could use the quadratic formula. Any one of those options would be great. If it was me, I would try to set it equal to 0, see if I could factor it or use the quadratic formula probably as the quickest way. And I need 2 numbers here. Multiply a times c, which is just going to be 1 times negative 27, and I need to add to get the b value, which is negative 6. I'm going to take that first term and drop the squared, put that at the beginning of each of the factors, which would just be x and x. And then the 2 numbers that will multiply to give me negative 27 and add to give me negative 6, only 2 numbers will fit both of those requirements. Negative 9 times 3, negative 9 plus 3. So one of my factors should be x minus 9. The other one should be x plus 3. Doesn't matter the order that you put that in. And then My two actual answers to the question for potential answers here, 9 and -3. And I'm just going to do a quick spot check in the original problem. If I plug in, just make sure you're not taking the log of a negative number. If I plug in 9 here, we'd get 27 minus 18, we'd be fine. Log of 9, fine. Now here, if I put in -3, that's going to give me -9 minus 18, which would take the log of a negative. Also, here, log base 3, if I plug in -3, we can't take the log of a negative number. So that -3 is actually what we call an extraneous solution. It doesn't work in the original problem because we can never take the log of a negative. So I just want to spot check that real quick. So my answer here is just going to be the 9. The -3 will not work in the original. So just make sure for your answers, don't take the log of a negative number because you cannot do that.